right, today we're going to talk about solving equations with variables on both sides. So as you can see, here are the state standards that we touch on today and our success criteria. So to be successful, you need to be able to apply properties of equality using variable terms, solve equations with variables on both sides, and recognize when an equation has 0, 1, or infinitely many solutions. All right, I've got the words underlined here that you need to be aware of. You need to be able to create equations, use and solve equations, understand, explain, construct, again, is the same as create equations, and justify a solution. Okay, you need to be able to solve, and you need to be able to represent solutions, both algebraically and graphically, and interpret expressions. All right, so remember these things as we get started, and we're solving equations. You should be able to do these things. Okay, looking at your vocabulary, this is something that you need to put in your notes. An identity. So an identity is equations do not always have one solution. An equation that is true for all values of the variable is an identity and has infinitely many solutions. So infinitely many solutions means there are limitless number of solutions. So make sure you know what the identity is. All right, key ideas: solving equations with variables on both sides. To solve an equation with a variable on both sides, use inverse operations to collect the variable terms on one side and the constant terms on the other side. Then isolate the variable. So very similar to what we did in previous lessons. So let's get started and see what we have here. All right, so example 1, we have 10 minus 4x equals negative 9x. So since there's a variable, an x, on both sides of the equation, the first thing we need to do is isolate or get the x on one side of the variable. One side of the equal sign. All right, so let's add 4x to both sides. So that cancels here, and we have 10 equals negative 9 plus 4 is going to be negative 5. We still have an x. Now we're trying to solve for x, so we're going to divide by negative 5 on both sides. All right, 10 divided by negative 5. 10 is the bigger number, so it's going to be negative 2. And like always, you should be able to plug this in and check it. Negative 4 times negative 2 is positive 8. 10 plus 8 is 18. Negative 9 times negative 2 is 18 as well. So when you plug that into both variables and check your equation, you can see that that is correct. All right, looking at example 2. Here we have parentheses so that we know that we're going to have to use distributive property as well. So let's go ahead and distribute first. So 3 times 3x is 9x. And then 3 times negative 4 is negative 12. And then we have 1/4 of 32x. 32 divided by 4 is the same thing as 1/4 times 32x. So 32 divided by 4 is 8x. And then the same thing here, 1/4 of 24. What's 24 divided by 4? That would be 6. All right, now that we see that we have a 9x and an 8x. So once we do distributive property, we can see that we still have a variable on both sides of the equal sign. In order to solve, we have to have the variable on one side. I tend to take the smaller number away from the larger number, so I'm going to subtract 8 from both sides, and that leaves me with a positive 1x. It's a little easier not to lose a negative sign if you already have a positive sign there. So x minus 12 equals 6. Add 12 to both sides. X equals 6 plus 12 is 18. And again, you can plug this in to check it. So let's check this very quickly and see what we have. All right, so if we have 3 times 3, and then 18, and then minus 4, okay, on the left side equals 150. Let's do 1/4 times 32 times 18 plus 24, and that equals 150 as well. So when the left side equals the right side, we know that that is correct. So that is a correct answer. All right, example 3, we have 0.5 times 6h minus 4. Remember, 0.5 is the same as 1/2. So what's half of 6? Half of 6 is 3, so 3h. Again, we're using distributive property. 0.5 or 1/2 times -4. What's half of -4? -2. And then bring down everything on the right side. And then I can see that I have an h on both sides of the equation again. And I'm going to try to get a positive variable, so I'm going to add 5h. Remember, you can only add like terms, so when I add 5h to both sides, I automatically put it with my variable. So I'm going to have 3 plus 5 is 8h. Bring down my -2, it's still there. Bring down my 1. So I'm going to add 2, and I'm going to have 8h equals 3. All right, I'm kind of running out of room here. I'm going to come up to the top of the page here. 8h equals 3. Since I have multiplication, I'm going to divide, and h equals 3/8. All right, again, I can plug in 3/8 and see if that works on both sides of the equation, and we can quickly check that. So I'm going to do 0.5 times 6. H is 3/8, so I'm going to plug in 3/8 here. And then minus 4. And I have to close that other parentheses too to ensure that it all gets multiplied by the 0.5 here. So hit enter. And that's the left side. So let's do the right side. So -5 times 3/8. And then plus 1. And that equals the same thing. So again, when the left side and the right side equal the same thing, you can easily check to see that everything is correct. So number 3 is correct as well, although the answer is up here. So I had to go all the way to the top to finish that. So this is number 2, and this was number 1. All right, so the next one is try it yourself. So I want you to take a moment, pause the video, and try to work this out and then see if you get the right answer. When you finish, you can start the video again to check your work. Okay, if you looked at this problem, it says your friend first multiplies each side of 1/2 times x plus 9 equals 3/4 times 5x plus 1 by 4 when solving the equation. Why might your friend do this? So I told you to try it, and if you do 4 times 1/2, then this equals 2, and 4 times 3/4 equals 3. So if you multiply by 4 first, what they're doing is first getting rid of those fractions. So let's try it. All right, so 4 times 1/2, let's go ahead and make that a 2. And then x plus 9. And then 4 times 3/4 is just going to leave the 3 times 5x plus 1. So if you multiply by 4 first all the way across, what that does is immediately get rid of the fractions, and it just makes everything look a little nicer and easier. All right, so 2 times x is 2x, 2 times 9 is 18, 3 times 5 is 15x, and 3 times 1 is 3. We're solving for the unknown. Again, I like to have my variables positive when possible, so I'm going to subtract 2x from both sides. 15 minus 2 is 13x. Bring down the 3. And then we're trying to get the variable by itself. So move the positive 3 over using the inverse operation. 18 minus 3 is 15. 13 x here. We want to find x. So divide both sides by 13. So our answer is going to be 15 over 13. Okay, so it said try it yourself. What I want you to do is take time to plug this in to the original equation here and see if you get the left side equal to the right side. And if so, that means you did it correctly and you can move on. All right, identifying the number of solutions. All right, example 4. First thing we're going to do is go ahead and solve the equation. So 3 times 5x is 15x. 3 times 2 is 6 equals 15x. Okay, if I subtract 15x from both sides, this is going to cancel and this is going to cancel, and that's going to give us 6 equal to, there's nothing over here, so 6 equals to 0. Is that true? No, 6 can never equal 0, so that is not true. So that means there is no solution. There is no solution to this question here. All right, so when it says identifying the number of solutions, a lot of times we get one answer, sometimes we get no answers, and sometimes we get infinitely many. So for this one, 6 cannot equal 0, so there's no solution. All right, let's look at example 5. N divided by 6 equals negative n divided by 6 plus 1/2. All right, so both of these are divisible by 6. So the first thing I want to do is get rid of those fractions. I can get rid of the fractions all the way across, like in the last example. We can multiply this by 6. So 6 cancels with the denominator here and leaves just n. 6 is going to cancel with the denominator here again as well and leave negative n. And then 6 times 1/2. So what's half of 6 would just be 3. So I'm going to bring down my plus 3. So what I did was multiply the entire equation by the same number, which makes this equation equivalent to this one. So it's equal to this one. It just looks a whole lot nicer without all the fractions here. All right, so I'm going to add n to both sides because, again, I like to have a positive number when possible. 1n plus 1n equals 2n equals 3 divided by 2. N equals 3/2. And 3/2 is the same as 1.5. So you can see that this one has one solution. So this one has one solution. Again, you should plug it in and check it. But to save time here, I'm going to move on to the next one. All right, example 6, I'm going to multiply by negative 2, distributive property. So I'm going to have negative 8y minus 2 equals negative 8y minus 2. You can already see that the left side and the right side are exactly the same. So if I add 8y and I add 2, everything cancels and I get 0 equals 0. Is that a true statement? Yes. So this means there are infinitely many solutions. So this one has all real numbers are solutions. Okay, so that means any number that you plug into this equation is going to make it true.